Alright, so today we're going to talk about how we construct a scatter plot. This is both an 8th grade Common Core State standard, and it's also an integrated algebra standard. So I've put these two standards here. So this top one is statistics and probability. It's 8 statistics and probability, and it's the first standard on the Common Core standard. So construct and interpret scatter plots for bivariate measured data, to investigate patterns of association between two quantities, describe patterns such as clustering, outliers, positive or negative association, linear association, and nonlinear association. So, and it's the integrated algebra standard, algebra, and a statistics standard 7. Create a scatter plot of bivariate data. Okay, so our vocabulary is scatter plot, negative, positive, and no correlation, linear association, and nonlinear association. Okay, so let's say that I measured two. Let's say that I am looking to try to figure out if there's a relationship between the amount of homework assignments one student does and the amount and the test grade that they get. So I measured 1, 2, 3, 4, 5, 6, 7 students. So these are all different students. These are all measurements from 7 different students. Let's say I arrived at this data. Now this data is called bivariate, B-I-V-A-R-I-A-T-E, data, because there are two, bi meaning two, so there are two measurements taken, the amount of homework assignments done and the test grade that was given. Okay, and let's assume this is homework done out of 10 possible assignments. Okay, and so I'm wondering, a lot of times if we wonder if there's a relationship between the amount of these two variables, we can make a scatter plot to try to investigate that relationship. Okay, so the first thing we want to know is what's the dependency? So what depends on what? So that we know what's on the x-axis and what's on the y-axis. So I would say that the test grade depends on the homework that was done. If I'm going to assume that there's a relationship, or if I'm assuming that there's a dependency here, then I would imagine that the dependency would go that the test grade would depend on the homework done. It's not always the case that one thing depends on the other when we're doing scatter plots, but sometimes it is the case. So I would want the test grade, the percentage for the test grade on the y-axis and the number of homework assignments on the x-axis. Okay, that means that let's look at our data points. So our data for the homework goes from 0 to 9. So I would probably want to start that at 0 and go to 10, incrementing up by 1 every time. I'm going to show you a better graph in just a minute. And the test grades go from 0 to 100. So if that's on the y-axis, let's have that go up by 10s every time. So here's a graph of what I showed you. Now, in order to take notes for this lesson, you can either decide to draw the graph yourself, or you can just make a list of the table that's shown here and sort of sketch the graph as I draw it. Okay, so in order to make a scatter plot, I should have homework completed. I should write on the x and y axis what exactly I'm measuring, and then on the y-axis is a test score. Okay, and these test score happens to be in percents. Okay, and so I'm going to graph the point 570. So 570 is here. Okay, that means for the person who completed 5 homework assignments got a test score of 70. So right now I'm going to pause the video so it doesn't become too long and plot the rest of these points. Okay, so I've plotted all the points that I have in my data set, and so you can see it's called sort of a scatter plot because the points are sort of scattered around the plot. Okay, the points are not forming a straight line. If I connected them, which I do not want to do, if I connected them, it would not be a straight line. Okay, or it would just be like a series of straight line segments, and you don't want to connect them. But there is a way to tell whether there's a relationship between the two. And tomorrow we're going to go over how we make a line of best fit, so how we draw a line that sort of fits these data points well. And we're going to get to something that looks at, we'll talk about it tomorrow, and there's an algorithm for it, but it's going to be a line like this. But going back to before we had the line, let's look at the way that these points are sort of associating. So it appears that the more homework assignments done, the larger the test grade. Okay, and I should actually title my graph too. So always come up with a good title that tells the reader exactly what they're looking at. So I would say maybe homework assignments completed versus test score. Okay. So it appears that the more homework assignments completed, the larger the test grade. So we call this a positive association, because as x increases, y also increases. As the variable along the x-axis, which in our case was homework assignments completed, increases, the test scores increases. So if it happens that as x increases and y decreases, and also as x decreases, y also decreases, then this is called a positive associations. These variables are moving in the same direction. Okay. Now let's say that I give you another set of data. So a group of children go out to an after-school program at a local youth club. The director of the program keeps a record shown below of the time and minutes each student spends playing video games and doing homework. So this is the video games, or this is the time spent in minutes. So this is the time spent in minutes playing video games and the time spent in minutes doing the homework. So if you were asked to create a scatter plot, again, we want to figure out what's on the x and the y axis. So let's say that you're just freely allowed to do whatever you want with your time. Then I would say that the amount of homework that gets done depends on the video games that the children play. Okay, so I'm going to assume that the video games are on the x-axis. I mean, it may not be like this for you. Your parents may not allow you to play video games unless your homework is finished. So for you, it may be the other way around. And in fact, it doesn't necessarily mean that they actually have to be have a dependent relationship. And we're going to go over that in just a minute. But let's assume that the games are on the x-axis and the homework is on the y-axis, which means I will have my games go up to 80, and they start at 20. Okay, so what I might want to do is I might want to start at 20. So I might want to make one of these little marks right here, meaning I want the space between the origin and the first dash to be 20 units, and then go up by tens every time. So I could do that if I wanted to. Or I could go up by tens every time up until 80. And my homework, it looks like the smallest I have is 10, and the largest I have is 50. So we probably will let that go up by 10 every time. So you can see what I have right here is I've made a graph that's almost like that. So on the y-axis, which is the homework, so the time spent with the homework. Okay, so I just went ahead and labeled all the axes and gave it the title. So my pen's not as precise as your pens would be, so it's a little bit messy. So I'm going to read it. The y-axis should be time spent doing homework in minutes. And you always put the units, because you don't know if someone is talking about hours, in which case maybe this was a plot across a week or something, or a month. And then the x-axis is time spent playing video games in minutes, and a good name might be the relationship between playing video games and homework. And so I'm going to pause the video and plot all the points that I have in my graph real quick. Okay, so I plotted all the points right here, and it looks like the patterns in this scatter plot, it looks like it has a different sort of relationship than the last scatter plot. So let's look at the last scatter plot real quick. It looked like the lines, or the points, were all had like a trajectory that looked like that. Now these points look like it's going to have a line that goes downward. So it appears that the relationship here is as x increases, y decreases. So as the amount of time spending video games increases, the amount of time spent doing homework decreases. Okay, so make sure to write that in your notes. That's what this is showing. And in this case, if this is the situation, as x goes up, y goes down, this is called a negative correlation or negative association. Okay. Finally, if let's say that a teacher's giving a test, and before the test she asks the students how many minutes each had spent the night before preparing for the test. After correcting the test, she prepared the table below, which compares the number of minutes of study to the number of correct answers. So she has this association here, minutes of study up here, and correct answers down here. Okay. Now, let's think about a dependent relationship, even though this seems like a natural dependency, but let's just see what that might be. The minutes of study, or the correct answers, may depend on the minutes of study. So I'm just abbreviating here. So this would probably be the y, and this would be the x. So I've actually already made this graph right here. So the minutes of study is on the x, and the correct answer is on the y. And when we plot the points are all scattered around, and it doesn't appear that it has, I could draw a line that went this way and would fit some of the points, or I could draw a line that went this way and it would fit some of the points. And we're going to talk about these lines tomorrow. But the points don't appear to have any clusters going downward or upward. Like these lines before here, these lines appear to be clustering going downward like this, whereas the other ones before clustered going upward. But there's no real association for these. So we say that this is no association. And the reason for this in the book, that the book says, is that because she asked the students how many minutes before spent the night before, and this is consistent with findings that show if a student crams or like looks at all the tries to study moments before the exam, or if it's a very large exam and covers a lot of material, if they try to study just the night before and not the entire week or month in advance, then oftentimes they don't. It doesn't necessarily correlate to how well they do on the exam. Okay. So correlation. I've been using this word. Let's define it now. Versus causation. If two variables are correlated, it means that there's a relationship between them. It does not necessarily mean that one causes the other to happen. That should be there. That's the word there. Maybe an outside factor that causes both variables to change at the same time. An example of this is studies show that as ice cream sales rise, the number of drowning deaths rise. Okay, does that mean... So there's a relationship between these two. As this one increases, this one also increases. So it's a positive relationship. Okay, and this does not mean, however, that the ice cream sales cause the number of drowning deaths. Okay, that doesn't really make any sense unless you ate the ice cream right before you went swimming and maybe got some sort of swimmer's cramp in your stomach and it caused you to not swim very well and possibly drown. But it doesn't necessarily happen like that. So a third factor that might be causing both of those things is the time of the year. So the time of the year, as the temperature increases, the ice cream sales increase. And as the temperature increases, the number of drowning deaths increase because people are swimming more often. Okay, so there's a third factor that's causing both those things to rise at the same time. So those two factors are not, they're correlated, they're related, but they are not, one does not cause the other. So this is a very common statement in statistics. Correlation does not imply causation. So just because two things are correlated does not mean that there's that one depends on the other or one causes the other thing to happen. If two variables have a causal relationship, that means that one does cause the other one to happen. So for instance, the amount of TV that you watch, as the amount of TV that you watch rises, your test score falls. This is a causal relationship because the more TV that you watch, the less studying you do, and the less studying you do, the lower your test grade is. Okay? The more television you watch causes your test grades to fall. Now, the associations that you can have, So like we saw before, the clustering here, and you should make a note of this in your notebook. So you should definitely write these down and make it doesn't really matter the units here, but you should make a sketch of the clustering that's happening right here, okay? So a strong positive correlation means that the points are clustered, and it mostly looks like if you draw a line through the points, or that hits most of the points, it would be going upward. So positive meaning the slope would be positive. A moderate positive correlation means that the points are not as clustered together. So if you see these first points, they appear to be, if you drew a line through them, most of them would appear to be near the line. Okay, whereas a moderate positive relationship means that if you drew a line trying to get like the average of all these points, some of the points would be off the line, but in general, they do still appear to be going upward. So the line that you could draw through the middle of these points would appear to have a positive slope. Okay, a strong negative correlation is the same as a strong positive correlation, but the line would have a negative slope. And a moderate negative correlation would be the same thing, where if you drew a line trying to get to the middle of these points, again, we're going to talk about this line tomorrow. This is called the line of best fit. Okay, this line would have a negative correlation, but negative slope rather, but most of the points would be not extremely close to the line. Not in terms of how strong, they're not clustered like these points are. Okay, and no correlation means that you could just very well draw a line with a negative slope as well as a line with a positive slope. There appears to be no relationship between the two variables. Okay, and that's the end of what we did today. So remember, these associations are important to understand. Positive, negative, and strong and moderate. And of course, no correlation. And so we went over one of each type. Okay, the relationship between playing video games and homework, that was a negative correlation. The time spent studying for a test the night before was no association. And the homework done versus test grade was a positive association.